Hello everyone, welcome back to my channel. Over the past few days, I've been practicing Kubernetes commands and the CKA related tasks on the Code Cloud platform. And I realized that while commands are important, but they are only a small part of the interacting with the real Kubernetes cluster in the product environment. Well, in real production environments, you also need to troubleshoot the issues, understand how microservices run on Kubernetes, and you have to negotiate with other teams about the SLOs and SLAs for applications, and build a monitoring system that helps you to observe the entire cluster. So that's why I decided to create this new video series about the Kubernetes monitoring and observability. In today's video, we will focusing on the core concepts, that is, what is observability and what are the three pillars construct observability, like the logs, metrics, and traces, and why do they matter? Well, before we dive into the observability concepts, let's step back and ask a important question. So why do we spend time setting up a monitoring stack on a local Kubernetes cluster? And what's the most important is the what benefits does it bring to us as engineers, no matter the ID support engineers and QA quality engineers and SRE, and also the developers. First, I want to say that by running Kubernetes cluster locally with tools like Kind or Minikube, we turn our everyday development environment into something much closer to the real production environment. And this will narrow down the gap between writing code and deploying it. And as the gap between our development environment to the product environment, when it comes to the time when deploy our applications on the test environment or the product environment, you do not need to make too much modifications to your original code. And this can, in some degree, can improve your efficiency of your coding. And you do not need to, and less modifications means less bugs and less risks that your modification will involve into your features. So here are the benefits of deploy a local Kubernetes cluster and add monitoring to stack to that. The first benefit, it helps you to understand the Kubernetes components from the perspective of the observability. For example, when we monitor a Kubernetes cluster, we naturally revisit the concept of the node, the pod, deployment, control plane, scheduler, and the API servers as kind of core components that construct the Kubernetes cluster and how they implement their responsibilities to make everything ready and goes fine to when we deploy a microservice application to the Kubernetes cluster. And also checking their logs and metrics, we can deeply understand their responsibilities too. This dramatically improves our abilities and the skills of the troubleshooting. So when it comes to really need to troubleshooting a product environment errors, and you will be more confident to do that because you have already familiar uh, the command to interact with the other components of the Kubernetes and jump from this node to the other node, such kind of stuff. And benefit two, that deploy a local Kubernetes cluster and add the monitoring tools surrounding the components of the Kubernetes cluster is it can reduce the gap between the local development environment and the test and production environment. I just like to say that a Kubernetes local cluster like established by the Kind or the Minikube is much closer to the real production environment than the Docker Compose does. And the smaller gap between the dev environment and the product environment, the fewer bugs it will introduce to the development environment were especially useful during the refactoring. And benefit three is local Kubernetes offers benefits. over the Docker Compose cannot, and the Docker Compose cannot provide to you. And some developers say that the Docker Compose is totally enough for me to doing the to establish it in the local development environment. They provided me a lot of benefits, and like I can set up the databases, Redis, and a lot of middleware, and easily to let them integrate it with the microservices I developed. But I want to say that the Docker Compose is simple, and when it comes to the scenarios, if you have to fix the issues or design the network associated features in your microservices application, and Docker Compose cannot provide so complicated context for your debugging and testing and do a lot of coding levels, and you cannot use the Docker Compose to implement that. But Kubernetes can give you the real network behavior and a real pod life cycle, and also the real workload, the separation, and such kind of the real cluster resource monitoring. And it also provided the ability to reproduce complex issues locally. So if you plan to become a cloud native developer, this area's knowledge is very essential to you. And the last benefits that the local Kubernetes cluster and also add monitoring to stacks, and to let the Kubernetes cluster become your local development environment. And the benefit it can bring is it can prepare for future topics like the Istio and the cargo CDs. And we're going to also add more details and more complicated context in the based on the Kubernetes cluster, which is locally established. And a complete cloud-native environment requires observability. That is to say, when we study Istio or Cargo CD next, we will need monitoring to understand the service meshes, traffic flows, and the rollout pipelines, and also the application behavior. So I think the observability is a foundation. And that is after we have a good understanding of the CKA problems and the basic component and a basic understanding of the components that construct the Kubernetes cluster. I think trying to add the observability tools or the monitoring tools surrounding the Kubernetes cluster can provide me and a more advanced perspective to understand the Kubernetes cluster and its the ecosystem. So here it comes to the monitoring and the observability. When we're trying to explain the idea or trying to understand monitoring, there are two terminologies we usually facing. That is the one is monitoring and the other is the observability. So when we talk about the monitoring, what do we actually mean? The monitoring is about checking predefined metrics or alerts. It just helps us to answer the question, what went wrong? But Kubernetes is a dynamic distributed system. Most failures are unexpected, comes from the interactions between services, and cannot be predicted with the fixed dashboards. So this is why the more accurate term observability and not the monitoring. The observability is more complicated. It tries to have the SREs or have the engineers answer the questions. What did the system behave this way and why did it fail? This achieves observability. We rely on three types of signals. The first one is the log, and the vertex, and then the traces. Let's examine the differences. Well, the logs tell us what happened at a specific moment and also the error messages who triggered the event and in detail the stack trees. In Kubernetes, the logs come from multiple layers, just like different components construct the Kubernetes cluster, and the components are also divided into different kind of layers too. the node logs, which is generated by the node level component, just like a kubelet, container runtime, such kind of components. And the pod logs are generated by your deployed applications running on top of the Kubernetes cluster. And we can treat it as the application layer. And also the control plane logs, which is the master node logs, and those are generated by the master node size, the core components, just like schedulers, API servers, control managers, and even the etcd. And the last one is the audit logs, and they're just a record of the user actions. And those logs are very long and detailed, sometimes become very noisy, but they are perfect for deep understanding and post incident analysis. And here we come to another pillar that constructs the observability. It is the metrics. And we know that metrics are numeric time series values. They are lightweight and efficient and ideal for dashboards, which every actions and records have corresponding timestamps. And when it comes to the cloud native, when it comes to the T stack, we usually use the Prometheus to help us to store the metrics data, because the inside of the Prometheus, it contains a time series DB, different from the object DB and even the RDMS DB. The time series DB are more friendly and designed focusing on the areas of time series data size, and the time series data size are the metrics are. So this is something about the observability of the metrics. And when it comes to the areas of the Kubernetes, the metrics are mainly comes from the CD advisor and Kubernetes. They have different kind of endpoints of the in the protocol of the HTTP, which expose a port and endpoint to provide the metrics data site for your or for Prometheus to subscribe. And also another component is the kube state metrics, and they are for object states, and the node exporter is provided the node layers metrics data, and it's just for the node level data site and in time series, and can subscribe by the Prometheus, and also the API server metrics from the control plane side to provide the details of the control plane performance. And the metrics help us detect performance issues, create alerts, and build auto scaling rules. And the last pillar, construct the observability, is the trees. Well, the trees shows how a request flows through multiple services. And this is extremely valuable in microservices architectures. For example, a single user requests a touch, and its request first comes to service A to service B, and then attached to the Redis, and then attached to the service C, and finally the result will be centralized to the databases. And the trees can tell us the information where the context information, like which service is responding speed is slow, and where is the bottleneck of the complete business requirement where the request goes through in the complete system, and where the retries happens, and where a service is causing a cascading failure. And to the T stacks were the tools to help us retrieve the dataset or the information of the trees from the system. And the system can be your microservices application, the middleware, and obviously Kubernetes belong to. It is also can be treated as the system. And so the Open Telemetry is now the industrial standards for generating traces. And the tools like Jaeger or Grafana Temple also helps to visualize the data, which trying to visualize the trees data on the dashboard, provided a more user friendly way to get the details of the context of the trees. So here comes the question. That is the how logs, metrics, and trees work together. While a real observability platform rarely relies on a single data type, and they just describe the whole story or the whole context by different perspective or different angles of data side or the monitoring data they can provide it. And so the logs give us the details, especially what exactly happened and the context and the type of the data of the logs are usually in text. And the metrics give us a quick signals, which the statistics or the indicators of the specific core SLA values is modified. And sometimes we can add the alert associated with the metrics. And the trees give us the full story of the request journey. So we add them together to like them to form a complete view of the cluster. And that is, if any part is missing, we lose part of the truth. So warp up all the things together, we can have a review of this video. In this video, we covered why Kubernetes monitoring matters and why observability is more accurate than simple monitoring when we talk about monitoring a Kubernetes cluster. And then we talked about three very important pillars to construct a observability. That is the logs, metrics, and the trees. And in the last, we know how they complemented each other to help us understand a distributed system. Well, this understanding will serve as the foundation of upcoming videos, where we will actually build a full monitoring stack using the Prometheus, Grafana, and Metrics exporters, and also the dashboards. So those are the topics we're going to introduce in the next video. And I think it is the end of our recording. Thanks for watching, and I will see you in the next part of this Kubernetes monitoring observability series. See you next time.